Hello students, this is Neelam. Today we are going to study chemistry subject for class 10 standard and this is basically session 2 for the same chapter, and the chapter which we carried out in session 1 was acids, bases and salt. What was the name of the chapter? Acids, bases and salt, and this is second chapter. Okay, now in first session what we studied? In first session we studied the reaction between metal like zinc with the acid and the metal with the base, right? Apart from that, we also studied the little basic introduction between acid and base, right? So but main reaction what we studied over there was the reaction between metal and acid and the reaction between metal and bases. Which metal we used over there? Zinc in the form of granules we used, and that zinc when it was reacted with a sulfuric acid and certain base, certain product was used to form over there. Now in session 2 we are going to study certain different activity or the reaction based upon that activity. Okay, now the second reaction wherein we are going to study over here is how do, this question is there, how do metal carbonate, metal carbonate. Now metal is the purest form of an element, right? So metal, which metal in this reaction we are going to consider one metal whose name is sodium, right? And the sodium has to be symbolized with Na. This is a symbolized form for sodium. So metal they are considering as a sodium, and carbonate is CO3. This is the symbolized form for carbonate. So metal carbonate, metal means they took sodium. Now sodium, they are Na2CO3 is a metal carbonate basically. Sodium carbonate we are saying, right? So this is the symbolized form or the molecular form for metal carbonate. Metal carbonate which we are taking over here, metal in the form of a sodium, carbonate formula is CO3, right? So how do metal carbonate and second one is metal hydrogen carbonate. Second one is metal, the same metal we are considering. First one is sodium carbonate, this is metal carbonate. Now second one is also metal. Which metal we are going to take? Sodium. Sodium is a metal, right? So sodium, that is metal, hydrogen, this word hydrogen is H, right? Sodium, hydrogen and again carbonate, right? So these are the molecular formula for metal carbonate and metal hydrogen carbonate, right? So what is the question over there? How do metal carbonate and metal hydrogen carbonate, I repeat once again, how do metal carbonate and metal hydrogen carbonate, right, react with acid? So acid will be dilute hydrochloric acid. We are going to consider over here the dilute hydrochloric acid. So how do thus this metal carbonate and metal hydrogen carbonate will react with acid? That is the question over here. So this question has to be answered by taking one experimental setup or by doing the one activity over here. Now they have took one experimental setup, right? Or we can say this is an assembly for show the reaction between metal hydrogen carbonate or metal carbonate with acid, right? So first we will study with the acid, afterwards with the base later on, right? But first we need to understand how this metal carbonate and metal hydrogen carbonate react with the acid. Now metal carbonate, which metal carbonate we are taking? Sodium carbonate, right? So sodium is a metal, carbonate is the form of that, right? So sodium carbonate is having a molecular formula Na2CO3, right? So this is an assembly wherein it consisting of certain apparatus. Let's understand first apparatus in detail, and then afterwards what are the ingredients involved into that reaction, right? So what are the apparatus consist of? First one is stand. You can see with the blue chalk whatever have been drawn over here, this is stand, right? Now this stand has a clamp, right, or clutch kind of a thing. So this clutch is holding one long length test tube, right? So in this test tube there is again a two thin tube like a structure which are inserted into the test tube. Now the first thin tube like a structure is called as a thistle funnel. What it is called as a Thistle funnel, right? What is its function? I'll later on discuss, but right now we'll understand what does the apparatus consist of, right? So first one is a stand, which consists of a clamp or clutch to hold the test tube, right? Now inside this test tube, now test tube is a container, one kind of a long length container within which we need to pour the ingredient or reagent so that the reaction will proceed out into that container or the test tube, right? So here in this test tube, two thin tubes are inserted over here. Now first thin tube is called as thistle funnel, which has a broader opening, and then the tube like a structure arises from bottom of it, right? So it has a broader opening at the top, and it has a one tube like a structure coming down and going inserting into the test tube. Then the second tube is called as delivery tube. What it is called as? It is delivery tube, right? So the delivery tube has two openings. Delivery tube has a two opening. One opening end is inserted into the test tube. You can see over here, and the another opening, the another end of the last end of the tube is inserted into the another test tube, right? So let's name this test tube 1, and this is test tube 2, right? So delivery tube has been inserted into two test tube. First opening has been inserted into test tube 1. The another end of the another test tube, another end of the another delivery tube has been inserted into the test tube 2. Right? So these two ends of the delivery tube has been inserted into the respective test tubes. Right? So that was all about the delivery tube. First one is thistle funnel, which has a broader opening at the one end and has a narrower tip at the bottom. Then second one, the second tube is nothing but it is called as a delivery tube. This delivery tube, first opening is been inserted into the test tube 1. The second opening, the second end of the delivery tube has been inserted or put into the second test tube. Right? Now first test tube is containing certain reagent. Second test tube is also containing certain reagent. Now first we'll focus upon the test tube number 1. Now in test tube number 1, it has a reagent. Which are the reagent which are present in the test tube number 1? Now the main important reagent which has to be put into the test tube number 1 is sodium carbonate. Sodium carbonate. And how do we write the sodium carbonate? Sodium carbonate is written in the molecular form Na2CO3. Right? So this is sodium carbonate. Right? So sodium carbonate, because why we are taking the sodium carbonate? Because the reaction has to be proceed between metal carbonate with acid or metal hydrogen carbonate. Now this is a metal hydrogen carbonate. Carbonate is CO3. Remember, carbonate is CO3, and metal, which metal we are taking? Sodium. Right? So sodium carbonate, metal carbonate has to react with acid. Now second reagent here which is included over there is dilute hydrochloric acid. Dilute hydrochloric acid, hydrogen chloride or hydrochloric acid. It is there in the form of a dilute form, right? So sodium carbonate is the first reagent, and second reagent is dilute hydrochloric acid. So this metal carbonate has to react with the acid. Understood my point? So this, the granules forms which are over here, it is a sodium carbonate, and this granules has to react with the liquid form of acid, which is hydrochloric acid. So when this two reaction is happening over here, certain product is evolved over there. The main product which is evolved over here is carbon dioxide gas. Right? So we'll write down the reaction, how the reaction is happening over here, but try to understand from the apparatus point of view, from the assembly point of view, right? So here, after reaction, carbon dioxide gas is evolved, right? So when dilute hydrochloric acid is reacted with the metal carbonate, sodium carbonate, carbon dioxide gas is evolved. So this gas, when it is evolved, it is passing through this delivery tube. It is passing through this delivery tube, right? So which gas is passing through the delivery tube? Carbon dioxide gas, right? So this carbon dioxide gas, which is having one opening at, which is inserted into test tube number 1, it has to enter into this delivery tube, and then this carbon dioxide gas will keep on traveling until it enters into test tube number 2. So which gas it is entering over there in the test tube number 2? Carbon dioxide gas, right? So carbon dioxide gas has been entered into the test tube number 2. right? So from where the carbon dioxide gas came? Carbon dioxide gas has been evolved after the reaction between sodium carbonate and dilute hydrochloric acid, right? Sodium carbonate and dilute hydrochloric acid. After the reaction, the main product which has been evolved from it is carbon dioxide gas. So carbon dioxide gas, or the effervescence of carbon dioxide gas, when it is going out from there, it has to enter into the test tube tube. Right? So when it enters into the test tube 2 is containing another reagent which is there in the form of a liquid or solution form, and the name of that solution form is nothing but calcium hydroxide. What is the name of it? Calcium hydroxide. So in test tube 2, calcium hydroxide is there. Right? So this carbon dioxide gas which has been evolved from the test tube number A and traveling through the delivery tube and enters into the test tube number 2, then it encounters another liquid or the reagent which is calcium hydroxide. So that carbon dioxide gas has to react with the calcium hydroxide to form some another product over there. So that we'll understand by writing the reaction in more detail. Understood here? So in test tube A, it was containing hydrochloric acid and the sodium carbonate. When they are reacting with each other, the carbon dioxide gas is evolved. This carbon dioxide gas, when it is evolved, it will travel through the delivery tube and then it enters into the test tube 2, where that carbon dioxide gas will encounter the another solution which is calcium hydroxide. Right? So this carbon dioxide gas will react with the calcium hydroxide to form another product. Okay? Okay, that was all about the apparatus or the experimental setup. Right? Apart from that, one more thing which I said you is Thistle funnel. Now, what is the function of Thistle funnel? Thistle funnel is having the broader opening at one end. So through this broader opening only you can pour dilute hydrochloric acid, right? So you can pour the reagent, this sodium carbonate, you can put it with the help of a spoon because it is there in the powder form, right? Whereas the dilute hydrochloric acid we need to pour with a certain funnel. Funnel is needed, no? So it is its function is basically to pour the liquid reagent through it. And then above that you can see this wooden kind of a thing which has been fitted into the test tube, so that the delivery tube and Thistle funnel should be intact with the test tube. Right? So this wooden thing is nothing but called as cork. Right? This cork is making sure that the Thistle funnel and delivery tube will be in tight fitted with the test tube, because whatever the gas which is evolving from the test tube A1, it should not escape into the atmosphere. Right? So it should travel only through the tube. Thereby it has to be fitted with a one lead called as cork. Right? So this is a setup or the experimental setup where it shows that when the metal carbonate is reacted with the acid, the thing has to produce certain gas has to be produced, and this setup is very, very important over there. Now, we have to understand this in form of chemical reaction. Whatever the reaction is happening over here, we should analyze what the reaction is taking place and how should be represented in the form of an equation. Then only you will understand in more detail, right? So here we should have to understand, right? Now the reaction occurring in the activity, whatever the reaction which is occurring in this activity, that has to be represented in the equation form. Now here test tube A. Now this is test tube A. Now here we have represented with 1 and 2, but now two metals we are considering. First metal is metal carbonate. Two reagents we are considering over here. First reagent was metal carbonate. Second reagent was metal hydrogen carbonate. So these are the two reagents. So in order to react this two reagent with the dilute hydrochloric acid, then it has to be represented with the two test tubes over there, right? So test tube A will be considered first with the metal carbonate. Whatever we have written over here, this is for metal carbonate, right? So let's understand this with the test tube A reaction happening over there. Now in test tube A, what was the main ingredient or main reagent we added over there? Metal carbonate. Now this metal carbonate has to be written as Na2CO3. So this is metal carbonate. Sodium carbonate is nothing but the metal carbonate. And after metal carbonate, sodium carbonate, what we added over here? Dilute hydrochloric acid, which is HCl, right? So I'll write here a little bit. Sodium carbonate is the first one, right? Now second one, which is the second reagent? Dilute hydrochloric acid, right? So this is the second reagent. Now after writing this reagent, what was evolved over here? Which gas was evolved over here? Carbon dioxide gas, right? So carbon dioxide gas I'll write as it is here, carbon dioxide gas, right? So it becomes very easy for me to write down the reaction later on. Now here whatever it is formed, first one, and what I had evolved from here? Carbon dioxide gas. So carbon dioxide gas will be going to evolve from the carbonate, right? So carbonate is having CO3 formula. CO3 is a formula for carbonate. From that carbonate, you know, carbon dioxide gas is evolved. So what is left over here in this reagent? Na2 is left and one oxygen is left. Na2 is left and one oxygen is left, because carbon dioxide gas is evolved from carbonate. So carbon dioxide formula is CO2. So 2 oxygen and 1 carbon has been extracted from it to form a carbon dioxide gas. So what is left over there is Na2 and 1 oxygen, right? So this Na2 and 1 oxygen, so I'll take this as a 2 HCl. Why I'm going to take 2 HCl? In order to make it balancing, right? So we'll understand here, right? So Na2 is 2, right? 2 sodiums are there. So this 2 sodium will react with the chlorine, 2 chlorine, to form salt, right? So this will be 2 NaCl, right? So 2 NaCl salt has been formed over here, right? So 2 Na and Cl has been formed, and here 1 oxygen is formed now. So this will react with the 2 hydrogen to form water, right? 2 hydrogen to form water. So this is the basic representation for the reactions, right? Right. So I repeat once again I will repeat over here. This is a sodium carbonate, Na2CO3, right? The main ingredient which has to be evolved over here is carbon dioxide gas. So let's remove that carbon dioxide gas from the carbonate. So CO3, from here carbon dioxide gas is removing out. Removing out means just extracting out. So carbon dioxide gas formula is CO2. So C1 and 2 oxygen from here. So C1 and 2 oxygen is removed from here. 1 oxygen is remaining, right? So what is remaining over here? Na2O, right? Now after that, when carbon dioxide gas is removed, the main ingredient which has to be formed over here is salt. Salt is nothing but NaCl. What it is? NaCl. Now NaCl has to form, but in NaCl there are 2 sodium. If 2 sodium is there, 2 chlorine has to be there. So thereby, in order to balance the equation, 2 molecules of hydrogen chloride has to be used. So 2 sodium will react with this 2 chlorine to form NaCl, right? So once it is forming 2 NaCl, what is remaining? 2 hydrogen and 1 oxygen. This will lead to the formation of water molecule. So remember this, children, that whenever sodium carbonate Na2CO3 is formed with the it's reacting with the hydrochloric acid, carbon dioxide gas has to be evolved, along with salt and water has to be formed. I repeat once again, sodium carbonate, whenever it is reacting with hydrogen chloride or hydrochloric acid, then carbon dioxide gas has to be evolved along with salt and water has to form. And the salt, basically common salt, NaCl is considered to be so common salt, because in sodium carbonate Na is there, right? So this Na will react with the chlorine to form NaCl. After forming NaCl, then water has to be formed. So general equation, if you have to represent this, sodium carbonate will react with hydrogen chloride to form salt, water and carbon dioxide. And after writing this, then you need to balance the reaction. And balancing of equation is has to be studied from chapter number 1. Right? So, but in this you just have to remind only one thing. Sodium carbonate, when it is reacting with hydrogen chloride, then salt plus water plus carbon dioxide gas has to be evolved. Salt in the sense, which salt? NaCl, right? Because from Na, means sodium is the main component over there. So Na and the Cl from hydrogen chloride, it will extract to form NaCl, right? So that was all about the first test tube. Now we'll understand the second test tube. Now in test tube B, we have to take another reagent. First reagent, which one we took? Sodium carbonate, right? Sodium carbonate, we'll write down like this here. then it becomes more easy. Sodium carbonate. This was the first reactant. Now in second test tube, we'll take the second reactant. Now the second reactant was metal hydrogen carbonate. What is the second one? Metal hydrogen carbonate. Now which metal we took over here? Sodium, right? So here also I'll take the same one. Metal hydrogen carbonate, right? So this is there. Metal, which is a sodium, hydrogen carbonate, right? So when it is reacting with the same acid, which acid? Hydrochloric acid. Hydrochloric acid. When it is reacting with hydrochloric acid, here also carbonate is there, means carbonate is there. Children, remember, whenever carbonate is reacting with certain acid, right, here carbon dioxide gas has to be evolved. So carbon dioxide gas has to be evolved, right, from the carbonate. Here also the same thing, metal hydrogen carbonate, when it is reacting with hydrochloric acid, from carbonate, carbon dioxide gas will evolve. So if carbonate, from that carbon dioxide gas is evolved, so what is remaining over here? NaH, 2 oxygen has been evolved, 1 carbon has been evolved. What is remaining? 1 oxygen will be remaining. Sodium, hydrogen and oxygen will be remaining in the first reactant. And then what is there? Hydrogen chloride. So whenever metal carbonate or metal hydrogen carbonate is reacting with acid, salt plus water plus carbon dioxide has to form. So carbon dioxide we removed. Then first reactant, first product, what it has to form? Salt. So what is that? NaCl. How come NaCl will be going to form? This Na will react with Cl, right? Na will react with Cl to form NaCl, right? And then how come water will be going to form? Again, the water has to form. The molecular formula for water is H2O, right? So one hydrogen is here, the another hydrogen is here. So this two will combine, H2O. One oxygen was remaining over here, no? So this will lead to the formation of water, right? So that was all about the second test tube reaction. What was the second test tube reaction was saying? When metal hydrogen, this is metal hydrogen carbonate, when it was reacting with the hydrogen chloride, it will lead to the formation of salt plus water plus carbon dioxide gas. We know that carbon dioxide gas is removed off. So initially we write down carbon dioxide gas because from carbonate, carbon dioxide gas will be going to get formed. So CO3 first lead to the formation of CO2. So one oxygen is remaining, right? So this Na will react with Cl to form NaCl, and H, one hydrogen, 2 hydrogen, this 2 hydrogen H2O, it will form as a water molecule, right? So this is the same reaction, only in Na2CO3 2 hydrochloric acid will come. In Na2CO3 2 hydrochloric acid will come. In NaHCO3 1 hydrochloric acid will come. Why it is so? Here 2 hydrochloric acid will come because 2 sodiums are there, no? Sodium carbonate is having a formula of Na2. So 2 sodium is there, therefore 2 chlorine should be there, right? So in order to balance out reaction, here 2 we need to write down because 2 sodium will react with the 2 chlorine to form NaCl, 2 NaCl molecule, and this 2 hydrogen will react with the 1 oxygen which is remaining out after removal of carbon dioxide from carbonate. This 2 hydrogen will react with the oxygen to form a water. So I hope children you people understood test tube A reaction and test tube B reaction. This is very simple, only we need to understand in more detail. I repeat, whenever sodium carbonate is reacting with hydrogen chloride, the main product salt plus water plus carbon dioxide gas has to be formed. Salt with salt, NaCl. Why we are taking NaCl? Because there is sodium. Sodium is there, na? So here also sodium is there. There also sodium is there in the form of a metal. So NaCl salt will form, and water has to form as it is. Carbon dioxide gas, from where it is coming? Carbon dioxide gas is getting evolved from carbonate. Understood my point? So that was all about the test tube A and test tube B. Now here, whatever carbon dioxide gas was evolved from test tube, this one A test tube, we are considering this as a test tube now, or first test tube. A test tube why I took? Because sodium carbonate is here, right, which is taking place in the test tube A, right? So test tube B is also the same thing. In test tube B, instead of adding sodium carbonate, I'll add sodium hydrogen carbonate. And the same reagent, dilute hydrochloric acid is there. No? Here also dilute hydrochloric acid is there. Right? So, dilute hydrochloric acid is remaining same. Understanding my point? So, sodium carbonate will be going to get changed by sodium hydrogen carbonate. Right? Okay. Now here what I mean to say here is that carbon dioxide gas, when it is getting evolved from the test tube A, it is traveling through the delivery tube, then it is entering into the test tube 2. The test tube 2 is containing what? Calcium hydroxide. Test tube 2 is containing calcium hydroxide. So whatever carbon dioxide gas is evolved, whatever the carbon dioxide gas has been evolved over here, that has to react with the calcium hydroxide. That has to be react with the calcium hydroxide over here. Right, so that we need to write down calcium hydroxide. So this carbon dioxide gas, so whatever the carbon dioxide gas has been evolved over here, right, that has to be reacted with this calcium hydroxide. So carbon dioxide gas, when it is evolved from here test tube, that will react with the calcium hydroxide, right. So this carbon dioxide gas has to react with the calcium hydroxide. Right, so the formula for calcium hydroxide is CaOH twice. CaOH twice. So this is also considered to be lime water. What is it? Lime water. So carbon dioxide gas, when it is reacted with the lime water, then what it will form? It will lead to the formation of calcium carbonate. Calcium carbonate. How come calcium carbonate? This calcium, this CO2 is there, no? From here, this, what is the meaning of this OH2 twice? OH2 twice means what? 2 oxygen and 2 hydrogen. Right? So this is the meaning of the word OH2 twice. Right? Means this 2 is applicable for 2 oxygen and 2 hydrogen. Subscript. After the bracket, whenever we are writing down in the form of a subscript, that means 2 are there. 2 oxygen and 2 hydrogen. Right? So calcium carbonate. How come calcium carbonate will be going to form? This calcium will react with this carbon dioxide and one more oxygen from here. One oxygen will go over there. Then how much oxygen is remaining? 1 oxygen and 2 hydrogen is remaining over here. Right? So 1 oxygen and 1 hydrogen is remaining means what? Is remaining what means what? It will lead to the formation of different component, which is nothing but this is 2 and this is 1. Right? Which is nothing but water. H2O, right? So, what is the formation over here? This calcium will react with the carbon dioxide and 1 oxygen will be going to get abstracted from the hydroxyl complex, which leads to the formation of calcium carbonate along with the water. So, this is really little different. If you analyze, then only you will understand. But at present, what you need to understand is that carbon dioxide, when it is reacting with the calcium hydroxide, it will lead to the formation of calcium carbonate along with the water, right? So this is calcium carbonate, which is going to get precipitated. Precipitate means at the bottom of the test tube, it will have the granules or precipitation of calcium carbonate. So that is the calcium carbonate. Right, so that is a reaction between the carbon dioxide and the calcium hydroxide complex, right? So I hope children that you guys have understood this in more detail, because here in this activity more of reaction is there, right? So first test tube was containing sodium carbonate, second test tube is containing sodium hydrogen carbonate. So both are getting reacted with the hydrogen chloride, and the main important product which is formed over here is carbon dioxide gas. Along with carbon dioxide gas which is getting evolved, salt plus water is getting formed, right? So whatever this carbon dioxide gas has been evolved, that will react with the calcium hydroxide, which is lime water, to form calcium carbonate along with the water, right? So I'll write this in the form of a word, then it won't be confusing for you guys, right? So I hope you guys understood this. Thank you so much.